Hi everyone. Let's talk about how to reduce the cybersecurity risk using the smart feature called Adaptive DDoS Defense. Before that, let's talk about the legacy DOS solution and some of its challenges. The legacy DOS solution works with hard set thresholds. Admin sets the thresholds manually and the traffic keeps changing. So this leads to missed attacks, tail drops, and false positives. The legacy systems also use tools like NetFlow, which samples the traffic but not full packet. This leads to the reduced accuracy. So the result, slow response and constant returning. The DOS protection on the EdgeConnect covers both external, which is WAN side, and inside network, which is LAN side. On the WAN side, EdgeConnect shifts the traffic to a better performing link when a DOS attack or a congestion occurs. This keeps the apps running smoothly. Features like stateful SNAT and harden mode ensures that the firewall blocks the traffic early and stops bad flows from being created. Even during a DOS attack, on the WAN side, the business continuity is ensured by seamless failover of the WAN links. Firewall protection profile is where the DOS protection begins. The firewall protection profile collects several network metadata, processes them to establish a baseline. The traffic threshold establishment has three dimensions: classification, which talks about whether it is a zone or a source based; metric, which is your flows per second, concurrent flows, or embryonic flows; and protocol, which is your TCP, UDP, ICMP, or other protocols. You set minimum and maximum limits, and then you define minimum and maximum action. The actions could be logging, blocking excess traffic, or blocking the source. This works great, but it is static. Every time you need to pick a number, tune them up as your traffic evolves. This is where the adaptive DDoS comes in. Let's look at the adaptive DDoS architecture. It is built over the standard DOS protection. It has two components: rate limit automation and smart burst, along with reporting. When there is a lot of traffic requests coming in, it could be malicious in case of DOS attacks, or accidental, a sudden spike in traffic. So this spike in traffic overwhelms the system, and then you start to see the packet drops and sometimes the total service outage. Let's talk about the auto rate limiting or rate limit automation. What is the biggest challenge in rate limit automation? Finding the right threshold. Every second, EdgeConnect is going to look at your flows per second, concurrent flows, and your embryonic flows. It rolls these data into minutes and hourly format. It repeats this over several days and sends the stats to the DOS subsystem. The DOS subsystem runs a mathematical computation method called 95th percentile, and it establishes a minimum dynamic baseline. So this is your minimum baseline threshold. This is a manual threshold. By auto rate limiting, it will learn the traffic and sets a new threshold. This threshold is learned, not guessed, and it repeats the learning process all the time. Once you establish a minimum threshold, the EdgeConnect knows and finds that as a normal traffic. Any traffic which is above this threshold is either flagged or dropped depending upon your policies. And you will control the maximum threshold because you need to cap the traffic. So now you have your minimum and maximum threshold, and the maximum threshold is going to set by itself without manual intervention. Now let's talk about the Smart Burst. Smart Burst feature is all about capacity management. Imagine your appliance has spare capacity and you have set the hard thresholds. So that will drop your legitimate traffic as well. Smart Burst fixes this by dividing the capacity into 3 levels. Committed baseline, which is the default allocated flow capacity for every participating zones in the firewall protection profile. Committed burst is the excess capacity allocated to all participating zones. Excess burst is the global bucket of all unused burst capacities that is available in the product. When a traffic flow enters the box, the flow is first allocated from your committed baseline. If there is no committed baseline available, then the flow is allocated a token from committed burst, and lastly from the excess burst. If none of these tokens are available, then eventually the flow is dropped. So these tokens decides whether a flow can be processed or not. Now let's talk about reporting. The rich adaptive DDoS reporting provides you both real-time and historical reports that covers peak trends, violation status, error drops, and top talkers, among other reports. These reports helps you monitor the traffic and make informed decisions. To wrap it up, with rate limit automation, you remove the guesswork. With Smart Burst, you get more out of your appliance capacity. Together, Adaptive DDoS Defense helps your SD-WAN network stay smart, secure, and efficient. For more information, please visit our website.